With that, let me say going into this that I have been working on my layout since 2006 was when we started construction. You would think in all that time it would be done, but it's not. And a very wise man who owned a local hobby shop told me one time that don't ever connect your track to complete your track work, because once you do, you won't care about scenery anymore. All you'll want to do is operate. And there's some truth to that. We have evolved into an operating layout. We meet the first Friday of every month, and we have usually 10 or 11 guys, and we just have a great time. But it seems that that's kind of taken on a life of its own, and scenery comes much slower now than it used to. But we are still working on it. I have the pleasure of working on it with my son, who has been interested from an early age. He turns 23 tomorrow. And I can tell you that's been one of the greatest things in my life, is sharing this interest with him. So with that, let's get going here. Okay. If you've got problems in your track work, nobody is going to enjoy operating on your layout. If there's a place where the train always derails, or the longer cars come uncoupled because there's a vertical curve, it just creates headaches. So it's really, really important to get your track work right. And if it's not right, in time, you will come to regret it. This was us working on the track work early on. I just realized here, Bob, that I can't see my notes the way I'm displaying this, huh? Is there any way around that?
No, I don't know how to do that. Can you see it when you run a PowerPoint presentation?
I think there's a way to do it. Yeah. It's like that speaker view thing.
That's what I need. Let me see if I can get back and
is there an
the
option?
PowerPoint could show
is there
that.
an option on PowerPoint that says show speaker view as well?
Well, it's show notes or something like that.
Oh
Yeah,
yeah,
note
speaker
view.
notes.
Note view is what I need.
I haven't used it in a long time, so I'm not sure.
Okay. All right, now, are you seeing my notes now?
No, we
No.
only see the picture. Do you see your notes?
All right. If I click, is it changing?
No.
Picture has not changed.
All right. Okay, well, I did not anticipate that. That's too bad. All right. Well, we're going to have to do this from my memory then. Frustrating. All right. Okay. Well, no matter what you do on paper, ultimately your design has to get transferred to the real world. And that's where the best design can go astray, because if you don't get it accurately drawn on your sub road bed, your plywood, whatever you're using, it doesn't matter how nice of a paper design you have. Have you all used one of these track planning templates? That is how we started out designing the railroad. Walther sells these. I believe Cotto also has a variation of this. And at the bottom there, you can see the different numbered turnouts. The top there shows different radius curves. This particular one is for HO scale, but they do make them for N scale and O scale. And that was pretty good. That allowed us to figure out our bench work. We wanted to make sure that we didn't have a cross member right where we needed a switch machine, which would cause a problem. And that was fine for getting started. track spacing is always a question, and people have different opinions. For us, I know the NMRA says that mainline straight track should be at a minimum of 1 13/16, so a little bit less than 2 inches. We've gone about 2 1/16 or 2 1/8 for our straight line track. And then curves, it very much depends on what trains you plan to run. If you're running 36-foot hopper cars, you don't have much of a problem even going with a 2-inch spacing. But if you're running auto racks or passenger cars or something longer, you want a little bit more spacing between your tracks. So we have about 2.5-inch spacing on curves. It may be overly generous, but I'd rather have too much than too little. In yards, again, everybody says, oh, 2-inch is good for straight track, but try and get your fingers in there between cars if you want to take something off the track or place a new car on the track. It's very difficult. We found that even arm length is an issue. So we set up the just a piece of track in our staging yard with the bottom left photo there to see how far you could reach in there. Could you really get to the track? And had we gone a little bit narrower, we might have been able to fit one more track into our staging yards, but we ended up doing 2.5-inch center to center spacing, as you can see in the bottom right corner. And that was enough to get your fingers in. And I'm not sorry we did that. For mainline spacing, these two mainline tracks here are on 2 1/8-inch spacing, center to center. But notice that meant with these number 8 turnouts that you needed to have a short piece of straight track, about 1.5 inches long, to separate those turnouts out. I think the natural tendency would be to say, oh, I can just take those 2 turnouts and place them so that they meet. But if you do that, I would argue that I don't think you have enough space between your tracks. Curve track radius, what should be your minimum radius? Well, I don't know how many of you run steam, and if you do, are you running things that are really long, like a Union Pacific big boy? Are you running short 2-axle switcher locomotives? You'll see a lot of times with a new product announcement that this car is designed to, or we recommend a minimum of 24-inch curves. I would say for the most part on our layout, everything we have is 24 inches or longer. We started out trying to do 30 and 32-inch for a 2-track mainline, but we found there were a few places where we had to cut corners just a little bit. So let your equipment dictate what your minimum radius should be. You may laugh when I tell you this, but we actually took curved track and laid it out at different radius, and then tried different cars, not for operations, but for looks. And I know a lot of people cringe when they see track sticking out from underneath a long car like that auto rack in the lower right corner. So that was the kind of thing we were trying to get a feel for. Will this look right? So once you answered the operations question, you had to answer, does it look right? And that's how we ended up coming up with 30 and 32. I see people with 36-inch radii, 48-inch radii, and I just think, wow, they must have awfully big basements. It all comes down to a balancing act between your track, your aisle width, and what you're willing to live with. Another issue that can become a problem is when you couple long cars to short cars, because when the couplers are mounted to the cars themselves rather than truck-based couplers, which most all of them are, you can see what happens with your couplers not wanting to meet. And you can actually have a train pull itself off the track because of that problem. We have a little scale test car that can't be any more than 25 feet scale length. And where does that cause issues if you put that in the middle of the train? So we usually try and put that at the very end of a train so it doesn't cause this issue. We have a helix, and it's 5 levels. We had to lay the track as we built the helix up from the bottom. So that was actually the first part of the railroad that we built. And it's 3 tracks. We have 2 railroads that share that helix. One is Conrail that has the outer 2 tracks. One is Chessie that has the inner 2 tracks. The Chessie line is local freights only. It's never going to see an 86-foot car. It's never going to see a passenger train. So it worked out fine making that inner track 27-inch radius. Then the 2 outer ones in turn are 29.5 and 32-inch radius. So again, that 2.5-inch between center lines so that you don't have to worry about cars ever striking a car on the adjoining track. Has anybody used these little things?
Yeah,
If I was starting from scratch, I would buy a set of these. They are very, very nice because they don't take up a lot of room. You don't have to have a long, long stretch of track to make this fit. They are really a great thing to use. They're expensive. They're about $9 a piece. So if you get a whole set, you're probably talking $60. But they are very useful little devices. Okay, a trammel is a tried and true way to lay out a curve. And we just took a yardstick and put a nail hole at 1 inch. And then we just remember that if we really are trying to do a 32-inch curve, it's going to be 33 inches. Then we drilled holes the size of a pencil diameter every 2 inches in the yardstick. And you can take that and you'll lay out a perfect radius curve. It works great. There's just one problem with that. How many times can you get to the center of your curve to mount that trammel to swing it? Most layouts don't have that ability. We actually constructed some temporary benchwork in the upper left corner here so that we would have a place to mount that trammel and swing the end of it to mark out the curve. It worked fine, but it's in hindsight, it was unusual that we had the ability to do that. Most people will not. Once this curve was laid out on the plywood, all that stuff in the upper left came down. It was just temporary so that we could get a starting point. There is a club in Berea, Ohio called the Olmsted Falls Motor Railroad Club. And I was there and I saw they have these plexiglass templates that they use for laying out their curves. They've got them all marked with what radius they are. They hang on the wall on hooks. And that is a wonderful way to go. I don't know how they got pieces of plexiglass cut to get those perfect radii on them. I have a hard time cutting a straight line in a piece of plexiglass, let alone a curved line. I suppose if you had the right type of cutting tool, you could do that. We ended up taking cardboard, just large 24 by 36-inch pieces of cardboard, and made our own templates. Each one of those is 2 inches wide. So one might be a 28-inch radius curve on the outside and a 26-inch radius curve on the inside. The next one would be 30 and 32. Next one would be 32 and 34. And those worked out pretty well. You just got to be careful to get the alignment right where you start. You don't want to suddenly veer into a curve and have to negotiate a curve that's even a tighter radius than what you're laying out. Now, I sent Larry a handout, and if you want to be real scientific about things, this is how they lay out curves on real highways and real railroads. Because they can't always get to the center of the curve, you're working along the alignment of the railroad or the road, and that's what you've got to deal with. So what they do is they carve out a central angle, and that's how far your curve is going to go from the beginning, or the PC, to the end, or the PT. And what they do is go straight out measuring to the PI, the point of intersection at the upper part of the photo there, and then turn your angle, which is the degree of curve that you're trying to lay out, and go out the same distance from the PC to the PI, from the PI to the PT. And I know it sounds complicated, but you can do this beautifully on your bench work. It does become a little cerebral, I guess, with all the equations, but it works fine. And it doesn't require you to have that ability to get to the center of your curve. So those are the formulas, and they are on the handout if you would like to do that. Another slide or two here, I've got a table that will show you the radius versus the degree of curve. So this is what they're doing here. We're laying out from the tangent line or the straight line coming into the curve. We make an angle that is half of the D angle. So if that's, say, 10 degrees, then D over 2 would be 5 degrees. We lay out a 100-foot chord, mark that point, turn the full D angle, lay out another 100-foot chord, and there you've got your curve. It does work. You got to work through it a few times to practice and make sure you're happy with what you're doing, but it is a tried and true, and it is the way real railroads would lay out a curve. An n degree curve turns n degrees in the forward direction over 100 feet of chord length. Does that make sense? So at HO scale, modeling 1/87th, 100 feet would be, let's get out my calculator here. A 100 feet divided by 87, that's going to be 1.15 feet. So you can lay that out, and then if you're trying to do a 2-degree turn, you know exactly how much you've got to turn to get that 100-foot chord. The thing, can you see my mouse? Does it show up?
Yeah.
Okay, you're trying to measure from right here to right here. This would be the 1.15 feet, and then that angle would be the same angle as here. So that's probably the easiest graphic that I can show you to explain how that works. And then this is HO, so I apologize if you're in a different scale, but the higher the degree of curvature, the smaller the radius and the sharper the turn. So let's just pick a radius that we all typically might use. Say in the right column, let's go to 24.254. That's a 24-inch radius curve. That's going to be a 33 degree of curvature. So that would help you lay that out to give you your 24-inch radius. I suppose you could work backwards so that these would be your even numbers, and these would be your odd degrees of curve. But typically in the real world, it's done based on the degree of curve. Okay, turnouts. At some point, you may enter the turn from a turnout. So you want your turnout radius to be consistent with the radius of the curve that you're going into. On the left there, on the table at the bottom, you can see a number 4, 4.5, 5, 6, and 8 number turnouts. And then you can go over to the 5th column that's highlighted with red there, and you can see what the radius of that curve turnout is. So if you're going, and you've always heard, you know, you only use number 4s for switching for, say, an industrial track. That's a 15-inch radius curve. That's pretty tight. If you're trying to do something bigger, you should be using number 5 or even number 6 number turnouts. On our main line, we use number 8 crossovers, and we use number 6 for sidings. We don't get into the number 4s or 4.5s unless we're in an industrial switching situation. Now, just when you think you have it all figured out, every brand of turnout is a little bit different. And here I'm showing a Walthers and an Atlas. These are both number 4 turnouts. But look at the difference in the length of the leg coming off of the 2 turnouts. Dimensionally, they're the same, but if you're trying to do, say, a ladder into a yard, you've got to be real careful of this, that you don't end up with your tracks too close together. So I just throw that out. We honestly have a box of left and right Walthers, Atlas, and Pico turnouts in number 4, number 5, number 6. And we will lay those out to use those as guides as we lay out our track. This is interesting. This is a Pico turnout overlaid on an Atlas turnout. And if you look in the Walthers catalog, you'll see that Pico doesn't make number 4 turnouts. Yet those turnouts to me look almost identical. So that's an Atlas number 4. I know that for sure. It is a Pico turnout, but I'm guessing maybe that's number 5. Pico makes number 5s and 7s. They don't make 4s and 6s, but you can see how close they are. So I kind of have to think that every manufacturer has designed their turnouts to fit what they think is the right number, and they may not be consistent with other brands. So that's why I recommend, I don't know what type of turnouts you like to use. We started with Atlas because they were available, and we've pretty much stuck with Atlas unless we had a need for a specialty turnout, say a curved turnout or something that we've had a few situations where we didn't have room in between tracks for a caboose ground throw. So in that case, the Walthers and the Picos are very nice because they're spring loaded, and you can just take the end of a pencil or a coupler pick and throw that turnout without having to have the hand throw. This sounds too simplistic to be true, but a long time ago, we actually photocopied, back when I was working and had access to a photocopier at work. We photocopied each brand of turnout and then had those available so that we could lay that out in a yard and see exactly how they would fit. And as long as you make sure that you're getting a good straight connection here, there's nothing wrong with that method at all. It works just fine. Just keep in mind that what you may have done on paper may not translate well to laying it out on your plywood. And that's something you need to keep in mind with all of this. You can do the most beautiful design on paper, but at some point it's got to become reality and be laid out on plywood. And it becomes especially critical if you're doing a lot of turnouts close together. This was just a masterful piece of work that my son did, and it's flawless. It works great, but he really scratched his head and did a lot of thinking to get this to do what he wanted it to do. And his goal, of course, was to maximize all the siding lengths so you could maximize how many freight cars you could store on those. Reverse curves is something that I think people ignore. I know we have a reverse curve coming into our housing plan, and every time when I drive that, I shake my head and think, how was that allowed? Because our municipal ordinance would not allow that, but our builder doesn't seem to feel he needs to follow that. So the idea here is that there should be a section of straight in between two reverse curves. And what they are recommending, and you'll see a lot of this is from the Combat publication on layout design, that there should be at least 60 scale feet in there, and more if you can. If you can do it, do the length of your longest car. So if you're running 86-foot flat cars, you should try and do an 86-foot straight segment in between your two curves. It really is important. The next slide, you'll see why. That's not a graphic out of a book. That's a photo I took while we were building our layout. So two 89-foot auto racks on a reverse curve with nothing in between the straight, or nothing in between the two curves. You can see what happens. Your train will derail itself. So they recommend 1 car minimum length of straight track in between the reverse curves. Some may choose to draw their track plan directly onto plywood or whatever sub-base material you're using. However, just remember, if you decide later on, that wasn't the best layout, let's do something different. That's why I like to do it on paper first and then transfer it over from the paper to the real world, because you may come up with a better idea that you didn't see at 1-to-1 scale when you're doing it on paper. Walthers and possibly other manufacturers now have track planning templates that you can download from their website. Those can be printed out to scale and used, as I mentioned, we had photocopied the turnouts, and it works great. It's just critical that you get the things straight, that when they meet, they're meeting at a straight line and not with an angle in there, because an angle can really throw you off. I had the luxury of a crew member, my son, who knows AutoCAD, and he was able to provide real life paper printouts that could be plotted on a plotter as PDF files at a scale of 1-to-1. We were able to take those, line them out on plywood, and use like an ice pick or a ponce wheel to mark the center line of the track onto the plywood, remove the paper, and then draw that out. And that worked beautifully. But I understand most people may not have that luxury. But that was fantastic. And we didn't have that early on, but as the layout grew, that was a skill that he added to his repertoire. Oops, blank slide. Okay. All right, grades. I think most of you probably know this, but not a bad review. The percent of grade is simply the rise divided by the run times 100. So if you climbed an inch in 8 feet, or 96 inches, the slope is 1/96, which equals 1.04%. And if any of you have done concrete work or done plumbing, what's that magic number? 2%, right? We always want to have a minimum of 2% to a drain line or to a sidewalk so that water drains off of it. So same idea, except you're doing it with track work. It's very difficult to rely on a bubble level. I have probably 4 levels, and one of them I trust, the other 3 I really don't. There's some that I have masking tape. It's got multiple bubbles on it. I have masking tape over some of them because I don't think they're accurate. They don't agree with the other end. Don't count on your floor being level, because floors in the basement, which is where my layout is, are typically sloped to get to a floor drain. So you can't rely on your floor being level at all. We have a drop ceiling in the layout room, and we have found, because that drop ceiling was put in with the laser level, that's pretty darn accurate. It's not a bad way to try and get things, elevations right on your layout, by measuring down from the ceiling. That gives you a pretty accurate reading if you know your ceiling's right. And again, I don't expect you all to run out and buy one of these, but I actually have a surveyor's level, and we use a yardstick as a rod, and that is absolutely the most accurate of all. I know, don't laugh, but we really did this on the layout, and it worked fine. On the left there, I'm showing the idea of measuring down from your ceiling, and that was not a bad way to go either. Now, how about when you combine curves that we've been talking about and grades, which we just talked about? Well, grades will differ on parallel curved tracks, because a tighter radius curve is going to have less running length to it, and therefore a steeper grade. On our helix, with the 3 curve radii, 27 inches, 29.5, and 32 inches, we actually end up in one revolution having a 2.36% slope on the inner track and a 1.98% slope on the outer track. Now, I thought as I was going through and updating the presentation this weekend, somebody might ask me, So what slope do you recommend? I can't give you hard and fast recommendation. I have found that different brands of locomotives are weighted differently and can pull different lengths of cars. Certainly it depends on what the cars weigh, but I've got some trains that will spin wheels on the helix, and we've got to send a helper set to help them make it. I've got other trains that do just fine on their own. So it's going to come down to experience and learning how many locomotives you will need to pull your train up the helix. Our helix, like I say, is about 2%, maybe a little more on the middle track or the inner track, but we always run at least 2 locomotives on a train, and there are trains that we've got to put a helper set on the back. But I love it. That's realistic operations. That's exactly how the main line here between Harrisburg and Pittsburgh works, getting over the Allegheny Mountains. So to me, that adds realism. That's not a problem. That's an operational feature. Vertical clearances. Don't forget to consider the roadbed thickness if you're putting your track on cork or something else. I guess Woodland Scenics now has that foam sub base that you can use. I've not used that, but I know a lot of people like it. We did a 1x4 as a vertical spacer on our helix to separate the levels, separate the layers. And that gave us 3.5 inches, because even though it's called a 1x4, the actual dimensions are 3/4 by 3.5. And per the NMRA gauge, they're absolutely right on the money. There's a double stack, which is the highest possible train we would ever run. We don't run double stacks, but we had one to use as a dimensional gauge. And you can see it's just about 3.5 inches for that ruler in the back. So when we put that double stack on our helix with no sub road bed, our helix is made out of a material called Micor, M-I-C-O-R. It's very similar to Homosote, but it is much less likely to change dimensions when there's moisture. Homosote, if you really want to keep it dimensionally stable, you need to seal it. And the Micor, you didn't have to do that with. But you can see we had maybe 3/8 of an inch of excess clearance with the double stack train. So we knew that helix was going to work for anything that complied with the NMRA standards gauge. If you look on that gauge, it talks about plate C equipment, and it's the largest possible car that you would see in use on the railroads. And again, it is spot on. It was a perfect gauge for the largest possible car. If you are doing the old tabletop 4x8 layout and you want to be able to come up and over your lower track, the slope is going to be dependent on how big of a radius curve you can afford to put in. So likely you're going to use your largest area you can fit your track into, but there is a formula there at the bottom. Your grade is going to equal the separation distance between your tracks over 6.7 times your track radius times 100. So you can figure out how steep your grade may have to be in order to get over that lower track. Now, this is really interesting. I had the opportunity 20 years ago to go to an intensive railway engineering class at the University of Wisconsin, and I got a 4-inch thick binder just full of information. But I think the most interesting thing I came away from that class with was understanding that when there's both a curve and a grade on a real railroad, the railroad will back off on the grade to try and keep the tractive effort constant, because adding a grade on a curve is going to make it tougher for the train to pull it. So if you want to be realistic, going into a curve, if you're trying to do a 2% grade, for instance, you may want to back off a little bit on the steepness of that. the third bullet point there, a degree of curve is equal to a resistance of a 0.04% grade. So take that 30-degree curve and figure it out. It adds a lot of resistance that your locomotives are going to have to overcome. So it is very realistic to back off on the grade. That's what we did on our layout. So if a railroad has a 1.25% ruling grade as an example, but with a curve of 25 degrees or a 32-inch radius in HO scale near the summit, the effect of the curve resistance can be eliminated by reducing the grade through the curve by 0.04 times that 25 degrees, or 1%. So a real railroad would reduce the grade through the curve by 1%, taking it down to 0.25. So the effective grade and the tractive force required from the locomotives will remain constant as if it was a 1.25% ascent for the entire length on straight track. Just a fun little fact if you want to be realistic. Okay, vertical curves. What the heck is a vertical curve? Well, a vertical curve is when you would look at your track plan from the side or a profile view, and you would see going from maybe level track to a 2% grade. You can't just do that at a track joint. If you try and make that abrupt of a change in your rail, you're going to end up with your trains coming off the track at that angle. So it's important to do a gradual change from the two grades, in between the two grades. You can do that with spacers. You can do that with, we've used those pieces you can buy at the lumber stores, a shim, and they sell long ones that are 12 or 15 inches long, and they go from maybe 3/8 of an inch down to nothing. Those are wonderful adjusters to start coming into your slope and make a gradual change. But you really should do some type of a transition between the two grades. All right, now spirals or easements. This is where coming into a curve, you gradually take the track and bring it into that curve radius. I don't know how many of you are in O gauge, and I don't mean to be mean about this, but one of the things that drives me nuts about O gauge is they take this sectional track, and 1 minute it's a piece of straight track, and the next minute it's a curved track. There's no transition, and you suddenly see this train come into the curve and abruptly have to lean into the curve to make it around there. And it just looks so unrealistic, so toy-like. So I think two of the greatest things you can do to make your track work look realistic is to use easements and to use super elevation. We'll talk about the second one in just a moment. But the idea here with the transition is that you gradually go from straight track to curved track to come into your curve. And I used to have a handout that was on 11 by 17 inch paper, and it had templates that you could cut out and mount onto foam core and use for laying out these spirals on your track. I've abandoned that, and I'll tell you why in just a moment. But this graphic shows the difference and the forces that are involved between having a spiral, say on the left side there. Using my mouse. This would be the radius of your curve if it was constant, coming right here. And then this would be what it would be without the spiral. It would just come straight through here. So you can figure out that offset coming into your curve, and there's actually a formula to come up with what it should be. My opinion, just use a 1/2 inch. A 1/2 inch is plenty. Take a 1/2 inch, offset the start of your curve, and then run it from there. Here again is another graphic showing the how you can lean into that. But I'm going to show you what we did. We marked that 1/2 inch right here, and the length from this point to this point, just like a reverse curve, should be the length of your longest car. that was the template that I used. That was from a article in Model Railroader in October of 1969. And if you want to, you can take these to a Photoshop printing place, and you have to blow them up, and then mount those onto foam core. And we religiously did this for a while, and then we just realized it was so much more trouble than it was worth. What we ended up doing is what I call the bent stick method. Get yourself a piece of lattice or a thin piece of lumber that has some flex to it. You don't want it to be too flexible. You want some resistance. You can see it. It took 3 guys to do this. But we lay that out on our track plan. The part closest to the bottom of the screen is on the straight track. And over here is our curve. And just lay that out and try and get this end correct and this end correct, and the middle will take care of itself. And then draw your line, and you've got your spiral coming into the curve. It works just fine. This again is another example too of having your plan on paper, but having to transfer it to plywood. So no matter what you do on paper, you still have to somehow get that over to plywood, and that's what we did with laying out the paper and piercing it to make some marks in the plywood, then come back and basically redrawing it. This is another extremely useful thing that we got at the lumber store. This is that imitation lumber or plastic lumber that they sell molding in. It comes pre-finished in white. It was just a thin piece of lattice, 8 feet long. We have used that for more things. It's one of the most useful tools on the railroad. If you're trying to measure track length, you can just lay this out on your track or on your plan for track and see exactly how many pieces of 36-inch track you're going to need. It's really been a extremely useful tool, and cost all of maybe $5. Okay, super elevation. This is the second thing I said will really, really make your railroad look realistic once you've got trains running on it. The key to super elevation is you want to elevate the outside rail, but you don't want to elevate it so much that the train tips over. So they talk about the equilibrium speed being the one that exactly balances the train through the curve. Well, I'm an engineer, but I don't have the knowledge to figure that out. Prototype railroads elevate the outside rail 5 to 6 inches. So what we have done on our railroad is to put plastic spacers underneath. Our maximum is 0.040. We just buy strip styrene and put a little sliver in there right underneath the rail. If you're center spiking your track using the holes that come in the track, you've got to put a piece half that thickness in the middle by the spike. Otherwise, when you put that spike down, you're going to start to bend your tie and pull your rails closer together, and your gauge is no longer true. So we put one underneath the rail and one in the middle, and then we transition. Our maximum is 0.040 on the outside. Well, as we start to come out of the curve, we'll put a 0.030 and then a 0.020. That's as thin as we've gone. Anything less than that, it's really even hard to see that it's there. But we've done that on every curve on our main line, and I think it really adds a lot to the look. And when you ballast your track, you don't see those little pieces of styrene in there. They just disappear. And I urge you with track work to keep it interesting. We found some old track plans of Pittsburgh that show industries that were once served by rail, and there's sidings that cross other sidings with Ys and turnouts and X's. They are fascinating. And for a switching railroad, some of those things are really a lot of fun. Like here was the main line, and you can see there was a siding coming off here into this building, but it crossed another siding that came off and went to this building. So you can do a lot of really fun things there to try and make it interesting. So for what that's worth, I think that's just something fun with an industrial railroad. There's one with tracks inside of a building. Okay, you get my point. All right, this John Armstrong book, Track Planning for Realistic Operation, that's where a lot of these graphics came from, so I give credit to him. It is a fantastic book. You can pick these up at train shows usually. Maybe somebody who's built their layout is selling their old book. And it's been produced a couple of times. There's several different editions, but it's a really, really good book. And I also say here at the bottom, don't be afraid to tear your track up and relay it if you find you've got problems with it. It's far better to fix it now than it is to run trains on it when all your scenery's done and realize this just isn't going to work for us. We did that with some turnouts. It increased our flexibility with operations. And yes, it was a kind of a pain to go back and cut track out and move turnouts, but in the long run, it was well worth it. I don't have any regrets about doing that. So that's as much as I have for you today. If you would like to visit the website, we do have a website for our model railroad, or if you just Google Pittsburgh Main Line, it will come up. And it kind of tells the story and shows some of the projects we did as we built the railroad. Now that we're operating, that website has not been updated for a while. I really should update it with our operations and explain how we operate the railroad. But it is a good resource to see some of the things we did as we built it. So with that, are there any questions that I can answer? Is everyone still awake?
Yeah, that was certainly more than I expected. And you know, I agree. You want the track to, you don't want any problems with your track, because if you have operations, that's a pain in the. But you got a lot of, practical suggestions in there too. That's a great presentation. Thank you, Andy. Has
Thank
anybody?
you. You're very welcome.
Was kind of overwhelmed.